My name is Andrew Lamb. I'm a staff engineer at Influx Data, and I'm also on the Apache Arrow and Data Fusion PMCs. So what I hope to do with this talk is I'm going to talk about, I'm going to give you hopefully a high-level overview of what Variant is, so you understand what it does, and then I'm going to go into some deep dive of like implementing it and making it fast or whatever. So if you're not really into like the low-level details of query optimization, that's fine. You can like tune out for the second half of the talk, but I think hopefully you'll understand after the first half what I'm talking about. So when people talk about Variant, what are they talking about? Like the primary, I think the major use case is storing JSON-like data in, I'm showing Parquet, but it's in the Iceberg spec. And so in this case, I'm showing a file that has two columns. It has an integer column, right? It's all you know and love, the structure column. And then it's got this variant thing. And I want to point out some details of the variant. Actually, like you can see it's structured in the sense that it's not just the same, like a single type. It's got fields, right, objects, lists and stuff. So it's structured, but the structure varies row to row. Right, so that's part of what semi-structured means. You can also have arbitrary nesting. I obviously can't put like an arbitrarily deep structure here, but the variant you can, right? So you can basically put whatever sort of nesting you would like in there. And then you can also have lists that don't have the same data type, right? This list has numbers and strings and the objects and stuff, right? So like if you're used to working with JSON, that's the kind of data you can put in JSON. If you're used to working with structured formats like Parquet, you can't put stuff like that in there. And so Variant solves that problem. So you basically load data that starts in JSON or some other semi-structured form. You can put it in Parquet and then apply all the technology from the big query engines stored in Iceberg and that sort of stuff. Right, so that's like the high-level overview of like what actually Variant is. And the rest of my talk, I'll go into some of the details of how it's implemented. So now why is Variant the big deal? We've had JSON for however many years already. Largely, it's basically performance, right? Anyone today can stuff a string into a Parquet file and get basically store semi-structured data in Parquet. The problem is it's much slower. I have no idea what this benchmark actually was, right? This is basically Databricks saying it's 8 times faster. But the real benefits but I basically believe it, and I'm somewhat skeptical of benchmarks in general. The reason is because Variant actually is a very clever binary encoding. It's got this shredding thing, which I'll talk about. And I think the fact that if you're going to store semi-structured data and query it quickly, basically people have now know how to do that quickly, and it's basically a fast binary format and shredding. And now that it has been standardized, I expect that the open source economics, right, and Flow will basically drive very fast query engine, drive the technology to query the stuff really fast across engines. So like that's why I think it's really important that it's been put into the spec. Not that it's interesting, or not that it's like fundamentally new technically. So this is more like, you know, a wall of text slide that describes the high level things about Variant. I'm going to talk much more. So it's basically, it's a new type. It's actually been added to this Parquet spec. It's not entirely finalized, but I don't really expect any technical changes between now and when it is finally finalized. It's in the official Iceberg v3 spec, and it's also was like Spark v version 4 that just got released can read it and write it. Right? So it's like this data type that's being driven through the ecosystem. And again, I think the major use case is if you have a pile of data that's stored as JSON, you want to put it in Parquet so you can query it quickly. That's the primary reason. All right, and I'm now going to like turn my head into, we're going to talk about how it's actually implemented in case you are into that low-level stuff, right? So I've told you it's got an efficient binary coding, and it's got the shredding thing, and now I'm going to try to explain what those mean and why it lets you do stuff quickly. So at a high level, the binary coding, I don't know if you're familiar with JSON, there's something called BSON as well, which is a binary JSON. I think Variant's actually better than that because of a few things. The first is it doesn't repeat field names, right? It's basically got dictionary encoded field names, which with JSON, with the same structure that gets repeated over and over again, that's very important. And it's also got a fancy way of encoding offsets so that you don't always like use 8 bytes or 4 bytes for little tiny objects when 1 byte would do. Like relatively simple computer science stuff, but important practical stuff in encodings. Before I launch into like a big discussion about how we're going to do this, I also just I'm part of the Apache Rust project. As an example of how exciting Variant seems to be, we started doing implementing Variant in the Rust implementation maybe 2 months ago, and all of a sudden we've got like a giant list of, I don't know, that's like 10 people, and there's been several more that have been contributing since I made that slide a couple days ago. So the point is a lot of people are excited about this, and I expect it to get driven through the ecosystem very quickly. Okay, so now I'll go through. Well, you might be asking, well, Parquet already has structs and lists. Like, how different is this really? And the primary difference I've already kind of highlighted, but I wanted to reiterate it again because it's important, right? Like, basically, why do you need a new data type in Parquet or Iceberg, right? Why can't you just use lists or structs? The reason for structs is that every struct you need to upfront before you store it in Parquet know exactly what all the possible fields are, and all the values for those fields have to have exactly one type, right? So you can't do stuff like this where you have two records with names that have the values are strings, and then one randomly has an integer, right? Like maybe your data isn't clean, for example. If you try to put that in Parquet, it would error, and so you'd have to basically have some sort of ETL cleaning process. Whereas variant, you don't. You can just put it in there. And likewise, the lists in Parquet, all the elements have to be the same type, whereas that's not the case in variant. That makes sense? Like so it's not just adding new random stuff to the spec because it's fun. It's that you fundamentally can't represent certain data with the existing types. All right. So variant encoding, I don't expect you at all to follow this example, but if you want to, I'll just give you like some high-level sense of why I was talking about dictionary encoding the field names before and what that actually means. In this case, if we're going to encode, I'm basically going to walk through an example of encoding this thing on the left, right, in JSON, which is a list of 2 objects, right? Each object has a field. The way that gets encoded on the left, variants are represented with 2 distinct pieces. They're represented with something called the metadata and then something called the value. They're 2 binary encodings. The thing in the metadata is effectively a dictionary, like just a list of possible field names. And then the value is the actual encoding of the nested structure. So in the example on the right, that's the actual value. You start on the outside, encoding the list. So there's like some header that says it's a list or an array. It says how many elements are in it. In that case, it's 2. And then after that, there's 2. The actual elements are then inlined. Right? So in this case, there'd be an object. Right? You can see it nested in there. I put an 11 in there. Right? That's the index into the dictionary. So the way you represent Andrew, first name Andrew Lamb, you have the field name encoded as a number, and then the actual value is encoded in line. And then similar for the other field, and then you've got the second object down there. Right? So this representation has a lot of nice properties. You don't repeal the field names. It turns out that actually you can, like those sub-objects themselves are valid variants. So you can actually sort of like look at a sub-object and not have to copy the bytes around to get another valid variant. And hopefully that gives you some sense. Like the encoding is very efficient. All right. The other nice thing about variant is I've been talking about JSON, right? I think that is the major use case for translating JSON and storing that type of data that's originally started there. However, JSON, if you've ever worked with it, has a bunch of challenges, especially around numeric data, right? Like it's kind of got a number, but it's not really float and it's not really integer. It's like something different. The fields, subfields in variant are actually strongly typed, so that it has proper integer types and proper floating point and timestamps and like all your favorite people, all your favorite data types are in there. So the point is you can actually do sort of more efficient structured processing on it. All right. The way it's actually stored in Parquet, aka how it's, again, we're getting really low in the weeds here. I told you that every variant is these 2 pieces, right? The variant and the metadata. Well, how is that stored in Parquet? It's actually stored as 2 distinct columns, binary columns, and they're grouped basically like a struct, right? So basically, internally, the Parquet file treats it as though it's a struct with 2 fields. This will become later important in a second. The metadata and the value and the binary value, and then it's got an annotation in the file that says treat this struct as a variant. Right, so that's basically what it is. So in my example picture here, right, if I've got a bunch of objects 1, 2, and 3, and I want to store them as 3 rows, the Parquet storage, you actually have 3 instances of the metadata. We'll talk about this in a second, and then 3 values, right, and the values point there. And so this basically also allows engines that don't know anything about variant to still read these files, right? From their perspective, it's just a struct, right, with two fields that they don't really know what to do with. But if the reader has been updated to understand variant, it'll be able to interpret and look at the subfields. So far, so good? All right. All right, so now we're going to go even deeper. All right, so I told you it's like very efficient. Another way it becomes efficient, if I go back here, I was kind of saying, well, you don't have to repeat the same field name over and over again, right? But if you looked carefully here, like, the metadata is basically going to repeat the same field names because each object has the same fields, which is very common, right? But actually, one of the beautiful things about Parquet is it already has an encoding in here so that you don't have to repeat values. So if it turns out in that previous case that the metadata was literally the same, binary, compatible bytes for bytes, the way it will actually be encoded in Parquet is it'll be stored once as another dictionary, like a second level of dictionary encoding, and the actual values in the Parquet file will just be indexes into that dictionary. So basically, if all your documents have the exact same structure, or you've optimized your writer very good, like it's going to be super, super efficient because you're going to store the field names once for the whole file. Okay, so far? All right. So that's the basic case. All looks good. Now I'm going to talk about querying the stuff. Oh, I guess I should talk about an arrow. I'm running out of time. I don't think it's important. Basically, this is the same picture as I just showed, but it's an arrow. And instead of the Parquet types, it's the arrow types. The important piece of this picture is that you can map basically one-to-one without copying the values around. And I think that's all I'm going to say about that slide. All right, so now I want to talk about queries, and I got to get to I got to work up to what shredding is, because people talk about shredding, like what the hell is that? So in order to explain why shredding is important or what it is, I need to start with how a query engine will actually query data that's stored in variant. So if what you're doing is you're running a query like this, which is basically looking at data, like at my previous example, it's got a bunch of objects, and you're looking for ones where the org field is CMU. This is the way your query plan would look. You basically would scan that, then you'd filter it, and then you'd project it. So what that would mean in practice is your engine would read all the data out, right? Read those two binary fields, and then for each one of them, go through and pick out the the value for the org field, right? With some new functions, would have to kind of walk over the fancy binary thing, and then you'd actually filter out the rows, and then the next level you would go and pick out the field you want, right? So the point is, you basically had to read all the rows out of the file in order to evaluate that, which is, if you're used to columnar file formats or high performance storage engine, that's a terrible thing to have to do. So what people have done, in this, what I'm going to describe now is called shredding, but it's my first job was at Oracle 20-something years ago, and the hot thing then was XML shredding, right? So which they basically took. What I'm trying to say is the same basic technologies existed for a long time, but what's important now is that this has been standardized in the spec, and so I expect it'll show up in a bunch of the engines. So it's called shredding, and effectively well, here you go. The first thing is, we'll get here, you basically pushed all the stuff into the scan, but you still got to process each row. So the shredding piece is basically taking this idea where one of the reasons why analytic systems that have columnar storage is so efficient is because you can evaluate the query without having to read the entire contents of the file. Right? You just read some subset of the fields and use that for pruning and a whole bunch of other things. But if you all of a sudden now have this basically opaque data type and there's no way to process it other than just look at it all, you slow the query rate down. So how do you get value back, right? What we're going to do is it's called variance shredding. And effectively what you do is you pull some of the fields out and store them in their own columns. That's the high level thing. So here's my example. Again, I don't there's not going to be a quiz or anything like that on this. So, but the way I'm just trying to give you a sense of how it works and how it's going to be fast. What actually happens is it's now two fields, but now you add a set, potentially more extra fields. So in this case, if I knew I was going to be querying on, and I cared about the values of the org column or the last name column, up front, right, the writer has to know this. You could basically store those fields in separate columns. And then the way it would look like to the query engine is that you've got the binary and metadata fields as before, but then you've also got an additional nested thing which can store the actual columns in line. Right, so I'm trying to illustrate that on the far right here, where you've got the metadata and value still, but then you've got the actual names have been stored, and that's a real Parquet string array, and you've got another array that has the orgs, right? And so the idea is you pulled that part of the variant out. Right? Does that make sense? And you stored it as a normal column where you can apply all the standard column store tricks. So the final piece you need to take a query like this, right? Which again, I don't know how many of you read query plans regularly. I do, but I realize it's not all that common. What this is just trying to show is this is a scan, it's pushed a bunch of things down there, and then it does this. The point is, it's both evaluating the filter, right? It's figuring out which rows it wants to match, and then it's also extracting the column that it wants. We push both those operations into the scan. And the key observation is, your query engine has to be smart enough to know that when you're asking for the org column, when it's looking at the particular Parquet file, if the org column's been shredded into its own separate Parquet column, the query engine needs to rewrite these expressions in terms of the underlying column. And if it's able to do that, now all of a sudden this query looks exactly like any normal Parquet query, and all the standard optimizations can apply, and you can apply, row group filtering and page pruning and all that great stuff. So anyway, yeah, that's how it's going to be fast. That's basically the thing. Yeah. So with that, that's basically my talk. I'll be happy to take questions for 20 seconds. But that's it. Yeah. Yeah, Edmundo.
Are both encoding and shredding part of the spec, or are they two distinct things.
Yeah. So the shredded, so that stuff I just presented is part of the Parquet spec, and consequently, it started actually in the Iceberg spec, and it has now been they moved it upstream to Parquet. I think technically there's still a big banner on it. It's like this is not yet finalized. The reason that is because there's only one implementation right now, which is the thing in Spark and Iceberg Java. As soon as there's another, at least that's my interpretation. As soon as there's another real implementation in another language that's complete, that someone has complete. I'm looking at Matt because he does the Golang one. Then we'll remove that like caveat from the spec. But I haven't seen any evidence that we're going to change the technical definition of it. I think it's basically done. Yeah. So anyway, thank you.